Hello there, Mr. Sutton here, bringing you the Algebra 2 4-5 Part 1 homework solutions on solving polynomials. In this one, we're going to be focusing on solving using factoring. For this problem, to solve the polynomial here, we're going to first check to see if there's any common factors we can take out. We've got it all zeroed out, so that's a good first sign. But looking at our common factors, these are all divisible by 2, and we can also take an x out of all these. So if I take out a 2x, that leaves me with an x squared minus 6x plus 9. And now inside here we can factor a little bit more. Things that multiply to 9 and add up to negative 6, that would be, let's see, 1 and 9 doesn't work. 3 and 3 works if they're both negative. So I've got the 2x that I took out initially. I have an x minus 3 and another x minus 3, so x minus 3 squared, all of that equaling 0. Now setting each of our factors equal to 0 and solving, we have x equals 0 for the 2x here, that zeroes that factor out, and x equals 3 for this other one. And we've got actually a double root of 3. We don't have to spell that out, but it's there. On this one, we have things on both sides of the equation. As a general rule, when in doubt, zero it out works pretty well with solving equations. So let's move everything over to the left side. So I've got 2c to the fourth minus 6c cubed minus 12c squared plus 36c equals 0. Next up, let's see if there's any common factors I can take out. These things are all divisible by, let's see, they're all even, so I can take a 2 out of all of them. And they all have a c, so I can actually take a 2c out. That leaves me with c to the third minus 3c squared minus 6c plus 18. And since I've got 4 terms, I'm going to try to factor this by grouping. So I've got the 2c that I initially took out. And for these first 2 terms now, I can take out a c squared. That leaves me with a c minus 3. For the next 2 terms, I can take out a negative 6. So that's going to leave me with a c and a minus 3 as well. So just to come back to the beginning, we have that 2c that still just keeps following us around. We have a c minus 3 that we can factor out of the stuff inside here, and that leaves the c squared minus 6 for its own parentheses. All right, let's set each of these things equal to 0 and solve. If 2c equals 0, then c equals 0. If c minus 3 equals 0, then c equals 3 is another solution. If c squared minus 6 equals 0, we can say then that c squared equals 6 if we add that to the other side. Then we square root both sides, and we end up with c equals, don't forget your plus or minus, radical 6, which we can't simplify any further. To get started on solving this equation, let's begin by zeroing things out and subtracting this 14p squared to the left side, and I'll stick it between the p to the fourth and the 40 there. I like to have things in decreasing order of exponents. Now, since I've got 3 terms and the first exponent is twice the second, and the last thing is a constant. This is a pattern called quadratic form, where I can basically treat this thing like a quadratic and maybe factor it, but I'm going to use p squared where I would normally just use p. So trying to factor this, let me think of things that multiply to 40 and add up to negative 14. Well, let me think. 1 and 40 doesn't work, 2 and 20 is no good, 4 and 10 works if they're both negative. So instead of writing p minus 4, I'm going to write p squared minus 4, and then I'll write p squared minus 10. Now I'm going to set each of these equal to 0 and solve. If p squared minus 4 equals 0, that means I can write p squared equals 4, if I were to add the 4 to the other side. And then if I square root both sides, I have p equals plus or minus 2. For this one, I can write p squared equals 10. So then p equals plus or minus square root of 10. For this problem, I've already got it zeroed out. Let me next check for common factors. Looks like I can take a z out of all 3 terms. That leaves me with z squared minus z minus 12. And just factoring the inside a little bit more, things that multiply to negative 12 and add up to negative 1. 1 and 12 is no good, 2 and 6 doesn't work. 3 and 4 works, positive 3 and negative 4. So I have the z that I took down initially. took out initially, bringing it down, and then we have z plus 3 and z minus 4 equals 0. Zeroing out all three of these factors, we end up with z equals 0 for that first one. Negative 3 zeroes out the next factor, and 4 gives us that last root. On this problem, I've got things on both sides of the equation. When in doubt, zero it out. Let's move that 27m cubed over to the left. And let's look for common factors. These are both divisible by 9, so I can take a 9 out of that, or just divide by it since it's a constant, but I'll take it out. We also can take out an m cubed since they have at least that for the exponent. So 9m cubed coming out of here. That leaves this first term as an m squared. And then 27m cubed divided by 9m cubed gives us a minus 3 over there. All right, so setting each of these equal to 0 and solving, if I plug 0 in for m in this first factor, that's going to zero that first thing out. 0 cubed times 9 is still 0, so we have m equals 0. For this next one, we can write m squared equals 3 if I were to add 3 to the other side, and then square root both sides. That'll give us m equals plus or minus 3. And that's it. For this problem, I'm going to first zero things out. So let me add the 32 over to the left side. And there's no common factors I can take out of this. So the next thing that my mind is kind of thinking here is we've got 4 terms. So let me try some factoring by grouping. Take out a v squared from those first 2 terms. That leaves us with v minus 2. And for the next 2, I can take out a negative 16, leaving me with v and minus 2 again. So I can take v minus 2 out of both of those sets of terms. And then we have v squared minus 16 as the leftovers. Setting each of these equal to 0 and solving, we have v equals 2 for that first one. And for this next one, I can add 16 to the other side and then square root both sides. So we end up with v equals plus or minus 4.